Good afternoon, everybody. Good afternoon. Welcome to the second session of the SABIA Biogas Workshop Series. My name is Tusang Moyo. I'll be facilitating this session along with Mr. Kondwani Banda, the SABIA board member who is also an organizer for the series. We're very glad to have everybody here. We'll just let people to continue to come in as we go. Well, so obviously we're going to make sure to just get started as soon as possible so that we have as much time as we can have for the Q&A session at the end. So just looking right now, we have one of our speakers here already. So we'll just wait for Andre to come in. But in the meantime, we can actually get started. So the way the session will work, we'll just make sure to introduce the speaker, they do their presentation, introduce the next speaker, they do their presentation, and at the end, we'll open up the floor for any questions. Also, during the course of the workshop, please feel free to drop your questions in the chat. If one of the speakers says something that you would like to comment on or you have a question about it, please put it in the chat. And then at the end of the session, we'll just make sure to go through every single question that has been proposed and presented to the speakers. And also, we are on YouTube. Every single session will be posted on YouTube if you'd like to rewatch or anything. So I actually make sure to put the link to our page below just so that anybody who's interested can subscribe right now. So yeah, the link to our YouTube page is right there. So feel free to drop a subscription so that you can not miss anyone, because all the past and future workshops will be posted to the page so that you can watch anytime, whenever it's convenient for you. So I see there's quite a few of us already in here. We might as well get started with our first speaker. Let me just see. Yeah, we might as well get started with our first speaker, Dr. David Tinarwo, because we're still waiting for our other speaker. I'll just make sure to reach out to him as we go along. So let me just give Dr. David his proper introduction. So, Dr. David Tinarwo holds a PhD in electrical engineering from the University of Kassel in Germany and is a senior lecturer in the Department of Physics at the University of Venda. He is a seasoned researcher with a strong focus on renewable energy technologies, particularly biogas, wind, and solar energy. His current research places special emphasis on bioenergy for animals, food, and plant waste, with the broader goal of supporting sustainable rural development. He's also an active member of the SABIA board, contributing his technical expertise and academic insight to help shape the future of biogas in South Africa. So everybody, please join me in welcoming our first speaker, Dr. David Tinarwo.
Thank you, Tusani. Let me just upload this presentation and we start talking.
Yeah.
Okay, thank you very much. I don't know. I wanted to put my face first, but I have already started sharing. Maybe if you don't mind, let me just try to see maybe this video thing can make me share my face. If I fail, don't worry, I will do that after I present. So as already have been said by Tusani, my name is David, and surely I really like this technology of biogas, and I have worked for quite some time with many colleagues from South Africa, abroad in other countries, and so on, starting long back, showing a great interest in the area. I really like it. I would like to sort of like change the tone. When we have these sessions, we talk of biogas, and our focus sometimes over weighs on the biogas issue, the gas itself. I have been doing that as well for quite some time. And when we were struggling to, make the technology acceptable and taken to the heights we were expecting, that's when I started realizing that maybe we may need to put more emphasis on some other area, but which, pulls together the issue of biogas. Right. Today, what I'm going to talk about is basically looking at biogas and circular economy. When we look at, integrating this, technology in farming for sustainable livelihoods in the communities. I like working with communities. My intention on this presentation, I just wanted to, I know many people understand, the role of biogas in circular economy. And yes, but I will also emphasize that. And I am more focused on looking at what we are doing in Limpopo, looking at real situations we are facing, our successes and our challenges, and what we are doing to even improve. In that way, trying to inspire those who may be having entrepreneurial mindset, and also influencing policymakers to start to accept that we can have a meaningful solution from this technology of biogas. Of course, it will be worth to start by reminding ourselves what this biogas mean to us. What is it? We know this is a gas which we get from digesting or digestion of organic wastes anaerobically, meaning to say the digestion, the breaking down of this organic material is done in limited oxygen conditions. And the result is a mixture of many gases, but majorly constituted with methane and carbon dioxide. Methane taking the bulkier part, especially when the process has reached its optimal level. The methane then takes the bulkier part, followed by carbon dioxide. Approximately 50 to 70%, if the conditions are very good, will be methane, and the rest will be carbon dioxide with traces of other gases, but coming in very small quantities. So that's why we focus on biogas as if it's methane, because we are just focusing on that methane which we can use, which we can, burn to produce heat and, do many things with the heating. And yes, this has been the talk and the emphasis of many of us who talk about biogas. But there is this hidden product which many people don't talk, or now we are talking about it more, is what is left when this little mass goes away from the organic material which we put in our fermentation chamber, which is a digester. If you can imagine, you have got 20 kilograms of cow dung. Someone is saying, why do we always say cow dung? Why not saying ox dung as well? It seems masculine are favored. When you talk of, good things, you want to say ox, oxtail, ox liver, and so on. But when it goes to dung, you say cow dung, you see. But anyway, that's how we call it. Say you have got 20 liters of cow dung, and you are extracting through anaerobic digestion methane from it, biogas from it, the percentage of the total mass of that organic material which comes out as biogas is very, very, very small. It leaves, and we mix this 20 kilograms of cow dung with another 20 liters of water to make the whole bulk of 40 liters of that slurry. And when you remove the gas, what do you remain with? Is almost like you are getting back what you put in terms of volumes. And to many people, and I've been watching it in many, villages where we installed these digesters, especially where they are not practicing any, farming, it will be spilling over, on the, floors and so on. And to them, it's like, is one of those, factors which they say it's not clean. Why? Because then when it is spilling over, it is making the place look dirty. But that slurry is gold, given the process which has passed through it, breaking down all the complex, structures of the organic matter into, simpler elements which can easily be absorbed by plants, becomes or makes it even a more important commodity than the gas itself. Right. So when we look at now a situation where one is at a farming place, maybe a farm, a smallholder farm, where you have pigs, you have got cattle, you have got chicken or poultry, or you are at a school where you have got, learners, and you have got toilets, and you have got food which remains, and also if you're practicing gardening, leftovers from the garden. All those are things which we have mentioned. In a way, if they are not treated well, they end up getting into our pockets, demanding us to, do the right thing so that the environment remains livable. So we waste money in trying to take care of the wastes. And if you were looking at me, I am actually raising my hands to say it's waste, and I put in quotes, because to me, that, especially when it is organic, it changes now from waste to another thing. So if we look at it as that way, and we now say, okay, instead of allowing it to go unchecked, allowing it to go without revisiting with the aim of, converting, making new products or making it more useful, then that can be a problem. But to us, it's no longer a problem, because we are now saying the waste can be converted. If it is organic, can be converted to energy through biogas, to fertilizer through this bioslurry. We can actually further treat it into liquid portion and solid portion, where you are going to apply it to your field as you wish. So by that way, we are keeping these products and materials in use, and we are also regenerating natural systems in this way, because we are no longer losing anything. Whatever was supposed to be a pollutant or, a waste which demands care, is now actually, we are now looking for it to take it back and reuse it. So if you look at biogas, you will say now biogas addresses all three of those aspects which we have mentioned above, when we are converting this waste into value. As I have already said, we can convert it to gas, which we use for energy, and we can also convert it to, fertilizer, which we used then to produce food. So what are we doing in Limpopo from the University of Venda? The University of Venda has been working in communities since 2012, starting by, raising awareness to communities of the gold they are sitting on without realizing. So we started off by demonstrating to say, from the West, you can get energy. But later we went on to even, start now applying that into some, farming activities so that they utilize both the energy and the fertilizer component. So we are running with what we are calling biogas-based renewable energy integrated farming systems, BB RIFES. That's how we are calling it. And the promotion is very strong. We are really, pushing hard in the province. We have managed to make youths register cooperatives, small, farming cooperatives, and some SMEs who are working in this field of farming with biogas. Now look at the focus. Initially, when we started, we were focusing on biogas. We had some SMEs who registered and hoped that they would get, market, they would get a lot of activity in, deploying these biogas digesters as a means of living. But it turned out that it was not easy. One, the acceptance of the technology is not yet to that level. Two, also, to be honest, this technology, many people want to say it is cheap, but cheap to whom? Because those whom we think are supposed to be the quick takers, they have got challenges. If you go with a system which is more than 50,000 for a household, 50,000 rands, to say we can construct you a digester here of say 6 cubic meter, which can generate gas if all conditions are okay, enough for a family of up to 6 people to at least have maybe 2 meals and so on. I always want to be very careful when we talk about these potentials of these systems, because when you get to practical situations, we are not getting those which are cited in publications and so on. So that system which can produce gas, which can at least cook for 1 to 2 meals of 6 people per day in good weather conditions and good feeding, or good feedstock put in the digester. That costs significantly high. I'm talking of not less than 30,000. So you can imagine these families are families, some of them who survive on grants. You cannot imagine that person to spare, money to buy a digester for cooking while he can go and pick maybe firewood for free to cook. So it is a challenge. Even if you say, you also integrate farming, then you want to also be honest to say you are feeding this digester by about 30 kilograms to 40 kilograms of cow dung a day. Then that means it's a small heap a day. But what amount of, or what size of area can that, be used as fertilizer and be sufficient? So again, it's a limitation. So to a household owner, to really own a biogas digester, we need to be honest. And this is what we are lobbying, even in government, for policy to say, we can also look at biogas technology just the way we did to solar home systems when they were introduced, when people were living in dark. So governments were very busy and so focused to say we want to put lights in houses. Now we also want to say let's now also focus at putting clean energy for cooking in the houses, because it is still one of such big difficulties which our communities are facing. So with the help of government, then good numbers of people, households can actually acquire, you see, such. And we are working on designs which may actually be properly integrated even in the RDP houses, so that it comes together with a digester which can be used to even process the human waste which is produced in the houses, and of course co-digested with animal waste if one has some animals, to boost the energy production in the homes. So this is a lobby which we are still doing, but the most important thing is the integration which we are talking about here of the biogas technology with farming. For it to be financially viable, it has thresholds to say what size of farming do you or are you doing? If it is a piggery, how many pigs are you running with? If it is poultry, how many, hundreds of layers are you running with? Okay, so and how much land do you have to do your crop farming? Because then you need to balance to say, okay, fine, I have my plots, I am doing farming. Now I want to, manage my waste here. Especially take, for example, you've got pigs. Definitely you will need to think about managing that, because if you don't, then the neighbors won't like you, because it will be smelly all over. So you will need that for, managing your waste. But that management of waste even brings more things to you. So you are making your relations with the environment, meaning social and typical environment, good, because you are not polluting, you are not creating undesirable conditions for people to live in. And at the same time, you are actually generating your commodities like energy, which you need. And this energy goes very, hand in the farming system. Remember, when you are doing piggery, the piglets, when they are still young, they need, ultraviolet, infrared lights, those which bring light and heat, but consuming electricity. So if you are generating gas, for you to see and improve the financial viability of your project, then you can turn the gas which is produced from your digester back into the farming energy needs, so that it is actually, replacing that you were supposed to buy from the grid and so on. And also the land issue, to say how much of the crops are you doing? Then if you have all these optimized, then this is what we are calling this BBREIFS model. And this is what we are demonstrating. We go to our cooperatives and sit down with them and start working out to say, look here, you want to do your crop farming. What do you want to do? We want to do cabbage. And so we start to work from the cabbage point of view to say, okay, fine. With cabbage, for you, you are 5 members of this cooperative. You want salaries every month. How, if you assume market is there, then how much, of this cabbage should you, take to the market, maybe per year, in order for you to be able to earn the desired salary and grow? Then we make those calculations. Then once we have got that land, then we know from cabbages always, when you are selling, you have got quite a lot of breakages and so on and so on. So those breakages, if you've got piggery, then it will work so well because it's part of the food of the pigs, which you can actually use and avoid only buying the feed from this processed food. So that way you are making your feeding of the pigs cheaper. And we work again to say, now when you start piggery, when do you break even with piggery project? And so on. Then we work with those optimized everything. Then put now, push it as a package to say, if you are doing this mixed farming of piggery, crop farming, and so on, then for you to break even and to start making profit out of your business, you need the thresholds off. Then we declare those thresholds, and they now do them. And that way, it starts now to, interest many youths, as we have already seen. We have, as I have said, we have already over 20 registered organizations, which are, already working. Some of them, others are still on their, starting stages, and we are assisting them. So we push the demonstrations of the model together with the cooperative development, nurturing these cooperatives. And we normally target to apply these systems in those areas which are not connected to the grid, because then we are maximizing the potential of the energy generated from these systems. Right, so in short, this a model, we can quickly see how it goes. If you have got livestock waste, then of course you put that livestock waste in the biogas digester, and it produces for you cooking and heating energy and fertilizer. The fertilizer goes to the vegetables and crop farming, and you sell both the vegetables and the animals to the market and start making money. And that way, communities start to, really be productive. We have got some examples already, as I have said. We are working currently at 8 sites in the province. If we include the university as well, we are having 9 sites where we are, practically almost there every day, because we've got our interns there. Some of these places are schools, others are just communities. But I want to hint on colleagues, especially those who are promoting this technology. We talk a lot about school systems. Maybe during the discussion time, people will be open to say to me, how many of our schools which are running biogas digesters are really doing it well? And also, who is really doing the operation or the running of these systems? What we realized is we installed systems in schools, creches, and so on. But to be honest with you, after 2 years, I tell you, it's disappointing to realize that some of the schools had totally forgotten about it. And you know what they do when you arrive there and they don't know you, and you show that you have come to see a digester because you heard there is a digester there. Yes, it will be still functional, but not used. They go to you, they take you to the digester, they start, talking about, this one, we are cooking, and we are really cooking, using the digester, and because they know that's what you want to hear. But if you are someone who is knowledgeable and who can analyze the system, you just see that, this system last worked maybe so many, months ago. I remember one time I went to a school. The principal was very, 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 strong, explaining when we were seated in the office. Then I said, okay, let's go there to see. When I got there, I know where to check. And west of this digester had a flow meter. Then I looked at the flow meter, and this thing was almost 3-4 years old there. And flow meter was below even 50 cubic meters. Then I was like, oh, I just tried to make my my calculations. And I said, over all this time, less than 50 cubic meter used the gas. What does that mean? 3 years. It means this thing, if it was used, it was just used when it was installed, a few days, maybe 50 days or less, if it was producing good. And from there, it never, got used. But what they do is, because they sometimes feed, and it takes time for the gas to go. Someone can go for a year and come back and light. As long as it has not been used, it will be there. So they show you the light matches, flame comes out, and they think you are satisfied. But they did not know that I had not come to see the system for the first time. I was actually checking. Then I said to the principal, I think, do you check when these people are cooking? Do they really use it? The moment and I did not want to give him, the opportunity to lie, because I did not want to spoil my relationship with him. I quickly then said, hey, you know what? I really know these systems. I have checked. I think it is not being used. You need to check. So now we were on the same side. Then he was saying, sure, you might be right. Because I think I last, I don't. Now it was coming clear that this thing was not being used. So my point here is, schools are not easy to operate these systems unless the school is so organized that it has specialized people to do that. So what are we doing to improve on that? We have devised a method where we said, let's look for funding for the trainees we trained in the technology to do internship in those schools and start operating and develop them into cooperatives. While they are operating, we organized them to start now the agricultural part, to do gardening, vegetable gardens behind the yards of the schools. So in some schools, they are doing so well, but also in other schools, they still have challenges of regular feed, because if you just do crop, it is not enough to feed your digester. You still need animal waste like cow dung. And cow dung needs to come from the communities. In most of these areas, communities are not, supportive to the extent of bringing cow dung for free. The moment they say cow dung is going to the school, they want money. And the moment they started to say they want money, then that won't work. So what are we suggesting and what are we recommending to these schools, these places, and so on? We are saying schools can also be very productive. And the curriculum of the schools now is, going towards that sense of production at the tender age. You see, now as I talk, there is a program the Department of Agriculture is running. I am forgetting the actual name. I hope if during the discussion, maybe I will get it, where they promote the agricultural management practice, practical agriculture in schools, capturing the children, the youths, to learn how to produce, because this has been neglected for a long time, and the effects are very soon going to be seen if things don't work for relations with other countries, where you depend on other countries on your food and so on. Then we will start to see that we need much of our local production. So it has to start from the infants when they are at school. So we are now promoting partnership of these cooperatives, SMEs, with the schools to do proper business-oriented farming in schools. And this farming needs to be properly balanced, mixed farming, which supports the curriculum as well as generating income which can pay those who are working there and find a reason for them to be there because they will be growing. That way, the digesters will be operated and will have feedstock, because if they are doing layers or piggery, they will get at least enough feedstock every day to put in the digester. And that way, we are actually, going with the principles of a circular economy, where those which we considered waste are no longer waste and they are producing. So communities which we work with include, as you can see, I've written Jinga, Tiani, these are in Venda district, and Siakamela in Bluebeck, and Mahoba in Polokwane, which is Capricorn District Municipality. We also have places in Sikukune. This digester, which you can see being fed, is in Sikukune. If you look closely, you can see the jacket there worn is has a logo, two logos. One logo is of Energy and Water SETA, and we want to thank them. They are very supportive of these initiatives, and they have sponsored for internship of 40 interns, which are distributed all over the province in the 9 sites and for 2 years. So earning a salary for 2 years. And there you can see she is feeding. And of course, the garden there is not the garden of vegetables. Those who know it, you know it is tobacco. But still, tobacco, if it was not a manure put there, it was going to use fertilizer if they would need to get more. And yes, there they are using the slurry from the digester. This one is a digester surrounded by vegetables. You can see the vegetables there are really green, very green. I will show, I think I've got a video which shows, the range of the garden. I see, this is the video, actually, which shows the range of the garden. All that garden is actually maintained. What they do is the slurry which goes, they dilute it, and, start putting it in the, irrigating, putting in the, and then further take it, the irrigation by drip and continue to irrigate. But already the plants would have got nutrients from the liquid manure which they put, and then put a lot of water. Because if you put too much of it also, it won't do well. All right. So typically, households which can manage this kind of system should have at least, a livestock like cattle. Look at this. They have very nice, head of cattle, and they are good and right people to operate this kind of systems. Because if you have got about 6 cows, you can safely, operate a digester which can give enough gas for a family of up to 6 people. All right. This is the picture which you see on my left there is of Tiani Secondary School. And this Tiani Secondary School, as I have said, we are getting a lot of support, and many people are getting so interested in coming and, joining the wagon of this change which we are doing. Tiani Secondary School, we introduced the biogas digester in 2017. And we have been in negotiation with the school. They had agricultural science as a subject. But we were saying, you are learners. Not all of them are going to university. Why are we not thinking of putting agricultural management practice. So we have introduced agricultural management practice there, and they are now doing it there. And we are very happy, and the projects, they are supporting that curriculum. All right, then of course, why biogas? Reasons are there. Reduce energy poverty, generate local jobs, provide organic fertilizer, cuts greenhouse gas emissions, builds climate change resilience. And of course, we do all this through cross-sector collaboration. We are collaborating with municipalities, we are collaborating with government departments, NGOs, entrepreneurs, and youths and women-owned organizations. This is just to give statistics of what we have already done in the province, and I have checked my time is no longer there. I need to rush a bit. Of course, this slide is showing the system framework of what we are doing, all the things linked together to say how do we integrate them to get it move as a business, like entity. So this flow diagram is showing the connections of the different, components of the farming systems, and where you need now to include these other cooperatives to get into the value chains of the farm produce, so that they create their own market, because the market which is existing there is not easy to penetrate. All right, then of course, we ask then to say, why should we wait? Where can we start from our own corners? We can start with the small scale biogas farms. We can also leverage school and municipal partnership. We can access national green funding and training, especially working with organizations like Energy and Water SETA. They are really very supportive in this area. And we are collaborating also with TVETs. And as I talk now, it is not only biogas. We are now integrating biogas with other forms of renewable energy. As you know, in the farm, you need heating, you need light, you need electricity. So we integrate with solar. And the solar we are going for is actually through circular economy again, following retired solar modules, and redeploy them, test them, refurbish those which need refurbishment, and redeploy those which are all right to farms, to small cooperative farms where they are used for solar water pumping, and the lights, which is not too intense. I mean, then they can extend their life and extend their time of not being a problem as waste. So we ask all of us to be part of this South Africa's clean energy transition. I thank you.
Thank you, Dr. David. That was a great presentation, very informative. I hope that everybody's been taking down their questions, which will be answered at the end of the session. So yeah, Meshach, sorry, may you please just hold your question for now until the end. We'll make sure, Manape as well, until the end of the session, we'll make sure to pose any questions that we have. You can even drop them in the chat. Otherwise, at the end of the session, we'll make sure to unmute so that you can ask away anything that you may have. So yeah, I'm going to reiterate, please, the chat is your best friend. If you don't want to forget your question, you can just drop it there. Then we'll make sure to get back to it as soon as we have our final presenter. So yeah, thanks again, Dr. David. That was a great presentation. Now, moving on to our next presenter, we have Mr. Andre Siebert. Let me just pull up the bio over here. So yeah, Andre co-leads a company that focuses on balance and integrity in both the workplace and the physical environment, which is Tightrope Integrated Services Group. Tightrope's work spans two key pillars, which is employee screening and workplace integrity, as well as environmental solutions that include biodigesters, organic waste management, and agricultural energy saving systems. His work champions the idea that achieving sustainability means striking a careful balance between resource limitations and human demands, both in how we work and how we interact with the natural world. Andre brings a practical, solution-driven approach to biogas grounded in real-world implementation and system integration. So everybody, please help me in welcoming Mr. Andre Siebert to the SABIA Biogas Workshop Series.
Good afternoon, everybody. Can you hear me?
Yes, we can hear you. We can see you as well.
Okay, fantastic. So I'm going to be sharing my presentation with you. So I don't going to spend a lot of time on biogas as much as the previous speaker has already done, and I don't think I need to reiterate what has been said, but I'll just refer to it as it has a role to play in our business. So let me just see if you can share what I have currently. There we go. Right, so everybody can see the slide, biogas in the circular economy, integrating waste to energy. Can everybody see that?
Yes, we can see it.
All right, fantastic. Okay, cool. Right, I'm just going to put this down. There we go, minimize that. There we go. So welcome everybody, as I've been introduced already. My name is Andre Siebert from a company called Tightrope Integrated Services Group. We're an agent for Agama Biodigesters. And it's an honor to host today's, not SABIA meeting, not Simon's webinar, sorry, SABIA meeting. We'll be exploring how biogas fits into the circular economy, particularly within the waste to energy application. So I think I need to bring to your attention that our business, the waste side of it, focuses specifically on organic and food waste removal. So we go to restaurants and farms and malls, and we collect food waste and we dispose of food waste. And there are very strict compliance regulations in the city of Cape Town, where we're from. And so we have to be very particular with having accreditation to transport and also dispose of food waste or organic waste. And there's also, as you know, a food waste ban, organic waste ban in 2027 that's coming actually countrywide and specifically also in the Western Cape. Right, so what we're looking at is the circular economy. What, how, and why the Agama Biodigester. So we are saying that we are agents for Agama Biodigester solution, and I'm going to go into the biodigester solution. It might tie up with what you've already heard from the previous speaker, but Agama has been around for a long time, and so Agama is a big tank, as it were, and I'll go into the details of it later on. So there's going to be the power of bioslurry. In other words, what is that all about? What is the slurry and how important it is? Our waste to energy strategy here in the Western Cape, specifically Tightropes, and then Tightropes integrated model, our pilot project, and then a policy and municipal opportunities. That is our agenda for today. This will be our roadmap to look at the biogas process, technologies, applications, and how all of these ties into the city of Cape Town and national goals for waste and energy. Right, the circular economy. So the circular economy encourages us to think differently about waste. Organic waste in particular has tremendous energy and agricultural value, as the previous speaker has also mentioned. Biogas technology helps close that loop. So from a linear waste to circular resource, traditionally we had you take, you make, you waste. Pardon me. The circular economy, the difference is you reduce, you reuse, you recycle, and you recover. Organic waste equals untapped energy plus fertilizer. What is biogas? Biogas is created when organic waste decomposes in an organic or oxygen-free environment. It's versatile, clean, and renewable. And the byproducts like bioslurry are equally valuable. So the composition, as you know, would be 60% methane and 39% CO2 from an anaerobic digester. How does biogas fit? Well, as I explained earlier on, it closes the organic loop. It reduces organic fuel reliance. In other words, when you rely on fossil fuels, you are like oils and stuff like that. We are running into a limitation as far as that's concerned. And focusing on biogas, it captures the methane before it gets releases, and that is why it is beneficial to the environment. The Agama Biogas Pro system is robust. It's a modular. It's perfect for decentralized settings, for households, for clinics, for schools, and even small farms. It's engineered for African conditions. It's a small-scale biodigester. It's built at 6 square meters, prefabricated units. It handles sewage, wood, food waste, grass, manure, fully sealed, and has a long-life polyurethane structure. The same material that they use for those dojo tanks type of thing. It's thicker than that, and it generates about 1.9 cubic meters of gas daily, obviously under the perfect conditions, and it doubles as a fertilizer generator. The technical specifications, I'm going to go in and show you that more in detail. So it's got about 50 liters, 4,050 liters. The gas storage is about 950 liters. The maximum gas pressure is 6.75 kilopascal. Materials is LLDPE, 8 to 11 millimeters thick walls. As you can see, it's a thick, robust construction. And the operating temperatures is 10 degrees Celsius to 40 degrees Celsius. So it operates good or well in those environments, those temperatures. As you can see, it's not a fragile system. It's a robust, reliable, engineered digester built to perform consistently and with minimal maintenance. So there's no moving parts within that BP6 biodigester that I'm referring to. So how it works, just an example. I'll just increase that for you, then you can have a look. So really what you'll see is you've got your effluent, which moves into, and then your wet organic waste material, which goes into the compartment. As it is anaerobic, there's no CO2, there's no oxygen. So you generate the gas as it gets eaten. And thereafter, the gas gets captured in this little compartment up here. Here's an expansion chamber, and there's a biogas output here. Then you have a effluent filter, of course, and then you've got the effluent, there's a gas filter as well, which prevents you from having bad gas in the air. There's an aerator as well, which also then makes sure that there's no bad smells which is generated, and ultimately you have effluent which is produced here, which is your fertilizer, which comes out on this side. Let me see if I can move it that way. Yeah, there we go. Normally you have got your bedrock. It lays on the bedrock. It's underground. Here's your ground level. And obviously the best thing for this process is for it to be a bit higher than what your ground, and maybe if you've got crops growing, vegetation growing, the best option is to put it a bit higher up so that when the water, the effluent comes out, you can actually, by drip irrigation, fertilize your lands, and that generates a lovely plants. We've got very strong root systems, big fruits. We've tested it, and it's amazing how this works. And obviously, to add to what the previous speaker has been saying, showed you those pictures of the beautiful crops that it delivers. So going to the future, we're quite excited. So just in essence, the organic matter goes in, the gas is stored, and nutriently rich bioslurry comes out. It's a clean, closed loop system. Applications in action, from cooking to agriculture to heating. Biogas and its outputs meet real needs on the ground. There's a growing adoption right across South Africa. So you can cook, heat, generate electricity. If you run it with maybe a diesel generator, you can cut off on the diesel and it co-feeds. Compressed gas for vehicles, it's being used as well. And then obviously the fertilizer for crops ponds and gardens, as we've already spoken about. I have a few clients who utilize. One client has got about 5 or 6 people. He's got a smaller unit, not the BP6. He's had his unit for about 10 years already, and that there's no maintenance. Only thing I did was there was somebody that worked in the garden, and they cut some of the pipes, so I had to reattach the pipes for him. And that machine of his generates about 7 to 8 kilopascal of power of pressure, and he is saying to me that his family they cook tea and coffee all day on the kettle, and then in the evenings it would cook a pot of pasta, and it takes about 15 minutes, 20 minutes, and he's got enough gas to live on that. If you obviously it doesn't have a very bright, strong flame, so you can't grill a steak on it, but you can cook water, and you can generate, cook vegetables, water, pasta, stuff like that. Then don't forget the brown gold. A lot of information about this. They talk about organic fertilizer replaces costly synthetic fertilizers. Many forget that the liquid output of a biodigester is gold, literally gold. Research confirms the bioslurry has comparable or better outcomes than synthetic alternatives in many cases. And if you look at the price of fertilizer now, I think the last time I looked at it was about 400 Rand a litre or something around there. So, what you can get from this biodigester is absolutely brown gold. It boosts soil fertility and moisture retention, improves crop yields. Potatoes, maize, and lettuce were the examples that we were using. Also useful in aquaculture, pest control, and composting. So why does it matter in Cape Town? Why did we decide it matters for us and we need to get going on this? So Cape Town generates approximately 400,000 tons of organic waste annually. Tightrope, our company, is a local rollout. And we plan on moving forward with biodigesters for estates, these housing estates, farms, hospitality, institutions that would need and would rely on gas to generate their food, to make food, as well as for heating, as I said, and also then for having hot water. It matters because Tightrope is a local company with plans to target estates, farms, hospitality, and institutions around there. So it's an important issue for us, and we wish, and plus the fact that there's a 2027, as I earlier said, 2027 ban on all organic waste to landfills, which means you wouldn't believe it, but landfills are full. Obviously, you can obviously understand that, but you would think that organic waste creates such a problem. But obviously, with the leachate and the methane, it is a huge problem. And so, Trade and Industry has passed legislation that says that by 2027, there may be no more organic waste going into landfills. And that is why we decided to attack this problem and to see if we can find a solution. So we're focusing on organic waste and food waste specifically, and then helping to be sorted at the source, separated at source, which then is a big challenge for us, but I'll get into that later on. And hopefully we can deal with this 400,000 tons of organic waste, which is generated annually in Cape Town. So the waste energy strategy. Now, what is our strategy? So the separated at source organic waste collection, that's important. So it's important to start at the beginning, at the source, where the waste has to be separated, so that when you cook, you have a specific container that you use for your food waste, the peels, the old food, egg shells, stuff like that. And then we take that, you collect it, and you then place it into a digester to create power, heat, and vehicle fuel while generating gestate as fertilizer. Remember, we said to you how important that fertilizer is, so don't throw that out. But our focus is not as much creating the energy, although that is an important point for us, is the energy creation. We are focusing on the waste aspect of it and the disposal aspect of waste, because people are not seeing the benefit of the the energy side of it, but they do understand the waste side of it, and then in that way we are getting for them to also realize that there's an energy benefit. So sort of back to front, but that is where we attempt to find a solution and to sell it to people. So Tightrope's integrated waste model that we have, we collect food waste from households. We're not just distributing digesters. We're building a full waste-to-energy ecosystem, starting with our Brackenfell pilot. Brackenfell is where we are situated. The aim is to have a fully traceable and community benefit. How do we mean? What do I mean by that? So we collect household and commercial food waste. We have a pod system, and that's a bucket system, but we call it a pod system for source separation, which we give to the participants in this project, and they would then separate their food waste in that way. Then that food waste will become feedstock for the digester, and also whatever we can't place in the digester, goes to composting facilities that are accredited as well. So in that way, we are getting people to focus on the whole circular economy model and to start separating at source. The point is also that your other waste streams, for instance, your recyclables, now become more recyclable in that they are not contaminated. And then your general waste reduces considerably. So that's a cost saving for the city in general and for the commercial enterprises who are making use of private waste removers. The pilot project that we have running for us is 368 units, flats targeted, weekly 25-liter organic waste pods collected, tracked by weight per unit, and food waste is split between the Agama digesters and the facility for composting, and then authorized facilities, alternative facilities. What is important to realize, though, is that you have to know that anything that's new, often people have resistance to change. It's a natural thing. So if you give people the 25-liter waste pods to work with, the first thing is, no, it's more work for me. I'm not really keen on this. But we've gone with the process of measuring weight per unit that is generated and incentivizing people in that regard. So in other words, people are now incentivized to put their organic waste into a separate container. And that helps us to get people to start doing the right thing. So environmental and social gains. So as I explained to you, City of Cape Town 2027 readiness for the ban, the 100% ban on food waste or all organic waste into the landfill. We've got clean energy and greenhouse gas reduction. There's jobs and skills development, as the previous speaker spoke about the skills development levy that is there for people that work. And of course, the SETA who gave them 40 learnerships, which is an indication of there's new skills being developed within this area. And then, of course, soil health and circular agriculture. For those of you who don't understand, you can't use the same piece of ground all the time, and because otherwise ultimately you take out all the nutrients out of the ground and then there's nothing left and it doesn't yield you any crops. But by utilizing the effluent and the sludge and slurry and the fertilizer that you gain from the biodigesters, you are actually regenerating those pieces of ground, especially in the rural communities where they don't have big land and they need to have smaller areas that can be more profitable. This becomes very important. Municipal opportunity. I explained to you about the organic waste to landfill ban, the National Waste Act compliance, carbon credits and green job creation, local energy resilience and waste reduction. So municipalities are facing mounting pressures to divert waste and reduce landfill use. They are under pressure. Biogas can ease the load and unlock green benefits if it is supported. So, summary and takeaway from this: biogas is circular, scalable, and immediately available. A Gamma biogas pro system is a reliable solution, as I mentioned to you, and the bioslurry is a valuable co-product. Tightrope is already integrating this into Cape Town's fabric. The technology is here. The need is urgent and the model is working. We welcome partnerships with municipalities, agencies, and communities. So guys, let's go. Let's build a circular future together. Always know that there's always challenges. I'm not saying nothing is without challenges, but as far as that's concerned, we deal with them as they come about. Here we go. Any questions?
Thank you. Thank you so much, Andre. That was a great presentation. Much, much appreciated.